This is Launch Complex 34 at Cape Canaveral, Florida. The size and complexity of the launch facilities for the National Aeronautics and Space Administration space program can best be explained by the man responsible for their design, construction, and operation, Dr. KURT H. Debus, Director of the National Aeronautics and Space Administration, Launch Operations Center at Cape Canaveral, Florida.
The majority of the rocket systems developed for military use have completed their research and development phase and are ready for their deployment and intended use. Some of these systems have been used by the NASA for the scientific exploration of space and are launched from Cape Canaveral. Actually, the space program of the United States had its beginnings with some of the military boosters. I would like to show you some of the models used in the scientific exploration in order to come to a comparison with the newest booster, the Saturn C1. Then I would like to show you the launch facilities required and developed for the Saturn C1. Beginning with the first satellite of the United States, the modified Redstone booster was used. Here is a scale model of that configuration. Using a modified Jupiter booster, other satellites were placed in orbit, including the Pioneer 4, which is in orbit around the Sun. Here are the modified boosters of the Redstone and the Atlas type, the latter one being used with the Mercury configuration in the current series of the U.S. Man-in-Orbit studies. This is a model of the Saturn C1, which is presently under design and engineering for the NASA. The model is made to the same scale as the models for the other space configurations. This increase in size, which is approximately, as you can see, double the size of the former space configurations, had to be taken into consideration for the concept and the design of the launch facilities. Permit me to use here a model of Launch Complex 34. The main elements of the Saturn C1 complex are the launch pad, which is approximately 120 meters in diameter. In the center is a launch table. 360 meters away is a blockhouse, which is a launch control center or the nerve center of the operations. This particular control center is igloo-shaped and contains two floors. The lower floor contains a telemeter station. The upper floor is a control center itself with all panels and instruments vital to the checkout and launch. Other elements of the 40-acre complex are the facilities for storage and automatic fuel transfer of liquid oxygen, liquid hydrogen, fuel and the transfer lines, as well as a high-pressure storage area necessary for the fueling of the space vehicle before launch. The most noticeable element is that of the service tower, which in servicing position straddles the space vehicle. The service tower is used to assemble, service, and shelter the space vehicle during preparation of the rocket for launch. After its job is completed, it is moved under its own power approximately 182 meters back to a parking position. This is considered to be the minimum distance in order to protect the tower from an explosion caused by a space vehicle falling back onto the pad. The design and construction of this tower was an engineering task and challenge of the first order. It is self-propelled, weighs almost 3,000 tons, is built to withstand hurricane winds of 125 knots, and this point is 31 stories above the ground. From here, you can get a good view of the various elements I described to you on the model. Incidentally, in the background are the launch pads used in the other programs at the Cape. Now let's look at Complex 34 and see it in operation.
This is the NASA symbol. Its likeness will no doubt appear on vehicles and hardware used in America's manned lunar landing program, which will be launched from a site here at Cape Canaveral, Florida. Beyond this gate is Complex 34, the largest known launching site in the world, and the first built expressly for the peaceful exploration of space. The dome-shaped structure in the foreground is the Launch Control Center, with 10,000 square feet of protected floor space on 2 levels and designed to withstand tremendous blast pressure. The 43-foot diameter spherical tank is for storage of liquid oxygen and, in reality, is a giant thermos bottle. Electrical, pneumatic, and hydraulic services are provided through lines on this 240-foot high umbilical tower. A 3-story pedestal supports and retains the vehicle during checkout and launch operations. The donut-shaped torus ring around the center opening is part of the water deluge system. High-pressure helium is stored in these cylindrical bottles. Helium is used for bubbling the liquid oxygen tanks of the booster to keep the liquid oxygen from forming into layers of different temperatures. The movable service structure is 310 feet high. It is used to erect and check out the vehicle. "10 days and 2,000 miles of water travel brings the Saturn barge to a dock at Cape Canaveral. The docking procedure is the final task of the barge and tug crews. Comparison of booster size can now be made. It is 82 feet long and 21½ feet in diameter. At dusk, the Saturn booster is making its last earthbound trip. Destination, Complex 34, some 2 miles away. The booster will remain on the transporter overnight and be erected the following day. Other stages have remained on the barge overnight. Work begins on their removal. Sheathed in a blue plastic protective covering is the second stage. The water ballast tank and nose cone are also covered for protection against dirt and dust. A slow but steady 2-mile trip begins for the transporter crews. The caravan passes through the gate at Complex 34, preceded by guards in the station wagon. The Saturn service structure dominates the skyline. Booster stage erection has begun. The stage is lifted by an overhead crane located at the top of the service structure. We can see the 8 H1 engines clearly. The inner 4 engines are fixed in position, while the outer 4 engines are movable to provide directional control during the powered flight. Lowering the booster onto the pedestal is the first assembly operation. The booster rests on 8 steel arms, 4 to support the vehicle, and 4 to both support and restrain the vehicle until proper engine ignition has been achieved. Technicians remove the plastic sheath. The second stage is then hoisted by the crane prior to being mated to the booster. The whole process is like a construction worker laying blocks. Another step in this block-laying procedure is to hoist the nose cone section to the top of the service structure. The nose cone cradle transporter is moved away from the immediate launch area. An explanation and briefing on Saturn erection procedures takes place at the base of the service structure. While high in the service structure, work progresses in lowering the third stage onto the second. Final assembly is complete. Now the long and complicated checkout begins. to determine Saturn's readiness to perform its intended function. This requires varied forms of communication between the many teams working toward the common goal of a successful flight. The assembly of the various stages has created the final configuration known as Saturn C1, which stands majestically while surrounded by the steel network of the service structure.